Welcome to our lab. I'm Danielle.
And I am Tatiana. Today we're going to be talking about liquid nitrogen.
Liquid nitrogen is the liquid form of the element nitrogen. Liquid nitrogen freezes at 63 Kelvin, that's about negative 346 degrees Fahrenheit. Whoa, that's cold. And boils at 77.2 Kelvin, which is approximately negative 320.71 degrees Fahrenheit under standard atmospheric pressure. A white mist is created by boiling the water vapor present in the air below the dew point.
Liquid nitrogen is an inert gas, colorless, odorless, non-corrosive, non-flammable, and extremely cold.
Although nitrogen is non-toxic and inert, it can act as a simple asphyxiant by displacing the oxygen in the air to levels below that are required to support life. Inhalation of nitrogen in excessive amounts can cause dizziness, nausea, vomiting, loss of consciousness, and death. Death may result from errors in judgment, confusion, and loss of consciousness that prevents self-rescue. At low oxygen concentrations, unconsciousness and death may occur in seconds and without warning. Safety. It's dangerous if you're not careful. If you touch liquid nitrogen directly, it can freeze tissue and cause severe damage. Protect hands at all times when working with liquid nitrogen because it burns. I still have a bruise. When spilled on a surface, the liquid nitrogen tends to cover it completely and intimately, cooling a large area. Use tongs, preferably ones with insulated handles, to withdraw objects immersed in the liquid and handle the object carefully.
Materials. For our experiment, we will need liquid nitrogen, a bouncy ball, balloons, and some pirate booties. Our first experiment will be with liquid nitrogen and balloons. When liquid nitrogen is poured over inflated balloons, the balloons shrink, and when it is warmed up, the balloons regain its original shape and volume. Because of the low temperature, the gas in the balloons tends to decrease, and the atmospheric pressure forces the balloon to a smaller volume until the pressure inside and outside the balloon are equal. When the balloon is warmed up, the pressure in the balloon rises and the balloon expands to regain its original shape and volume. We can see Charles' law in the experiment between liquid nitrogen and balloons. Charles' law is represented by the equation V1 over T1 equals V2 over T2. The first balloon is a gas-filled balloon at room temperature. The second balloon is a balloon lowered into liquid nitrogen at negative 196 degrees Celsius. The third balloon is a balloon shrink as the gas volume decreases. When the balloon is removed from the liquid nitrogen, the gas warms and the balloon expands. The fifth balloon represents a balloon at room temperature that regains its original shape and volume. Because liquid nitrogen is such a cold liquid, energy is transferred from particles in the balloons to the liquid nitrogen. Due to this, the particles in the balloon lose energy and get closer and closer to each other, reducing volume. When the balloon is taken out of the liquid nitrogen, particles in air transfer the energy to particles in the balloon, and the particles in the balloon have more energy. They start to separate from each other rapidly. Particles have enough energy to hit balloon's wall and cause balloon to expand.
We also placed a rubber bouncy ball in the nitrogen for about 10 seconds for the first time. We took it out and the ball was still a little bouncy, so we tried it again and placed it in the nitrogen for about 20 to 25 seconds this time. And when we took it out and tried to bounce it, it shattered like glass. This happened because temperature affects the bounce of a ball. The gas molecules in the ball contracted and caused the energy to decrease. The higher the temperature of the ball, the higher the pressure, therefore causing a higher bounce. On the other hand, the lower the temp, the lower the pressure, therefore causing no bounce at all, and with enough force, thanks to Hallie, the ball will shatter. Clean up, everybody do your share. For disposal, we just pour generous amounts of the leftover nitrogen on the tabletops and floor. The nitrogen covered the floor for approximately 3 seconds and then it evaporated. It was nice seeing all the dirt it picked up off the floor. Ms. Lulu could probably just use liquid nitrogen to clean her floors from now on.